this is an example of lesson 6.6, just a review problem. So just watch up here. A magazine reported that 6% of American drivers read the newspaper while driving. Kind of an old example probably, because now it'd be texting probably, or reading your Nook or your Kindle or whatever. But anyway, before all those things, a lot of people would, I know like a salesman, for example, that I knew, he would drive down the interstate and he'd read the newspaper on the steering wheel while he was driving on the interstate. You know, pretty dangerous, but people used to do that. Maybe there are a few that still do it. But if 180 drivers are selected at random, what is the probability that exactly 4 read the newspaper? What is the probability that more than 4 read the newspaper? What is the probability that at least 4 read the newspaper? So I want to talk about how to set this up and how to find each of these. Now, in last chapter, we did something called a binomial probability formula. That could be used to solve this problem. But the problem is you'd have to do, in the calculation, 180 factorial. So 180 times 179 times 178, etc. You get these huge numbers, and a lot of calculators won't handle them. You won't be able to get an answer. The calculator will give you like an overflow error or something like that. So another way you can solve these problems, other than the binomial probability formula, is to use a normal curve. But you can only use the normal curve if certain conditions are met. Those conditions are that n times p has to be greater than or equal to 5, and n times q has to be greater than or equal to 5. If both of those are not greater than or equal to 5, then you cannot use the normal curve. So let's figure out what n and p and q are, and then we'll determine if we can use the normal curve. So n is going to be your sample size. In this case, we're talking about 180 drivers. So n is equal to 180. P will be the probability that if you go up to a driver and ask him if he or she reads the newspaper while they're driving, they would say yes. Well, what are the chances someone's going to say yes if you walk up to them? 6%. Yep, so P is 0.06. Q is the probability that they won't read the newspaper, which would be 1 minus 0.06, 0.94. So to see if we can use this method or not, we need to take 180 times 0.06. And we need to take 180 times 0.94. As long as both of those answers are 5 or bigger, we can use this method. We can use the normal curve. So in this case, if you take n times p, you get 96, which is definitely bigger than 5. And if you take n times q, do that right? Sorry, I'm looking at the wrong problem. My fault. Yeah, way too big. Okay, if you take n times p, you get 10.8. Excuse me. That sounds better. If you take n times q, 180 times 0.94, you would get 169.2, I believe. So both those are greater than or equal to 5, so that means we can go ahead and use a normal curve. The other thing we have to find is we have to find the mean. The mean is found by doing n times p. So right here where I did n times p, that's actually the mean. The mean is actually 10.8. So remember that the mean on a binomial distribution is found by doing n times p, which in this case comes out to 10.8. So in other words, if you have 180 drivers, and on average, out of those 180, 10.8 of those drivers would read the newspaper while they're driving down the road. Okay? Now, of course, that would be true. One time maybe you survey 180 drivers, you get 11 people that do. Another time maybe you get 10 people that read the newspaper. Another time maybe you get 5. But the idea is that most of the time, if you survey 180 drivers, most of those results are going to show that around 10.8 drivers read the newspaper while going down the road. There's a few that read. There's a few times you get far less than that. A few times you get far more than that. But you get this bell-shaped distribution. I know you can't have 10.8 drivers. You either got to have 10 or 11, right? Well, that's one thing that kind of makes this a little bit trickier. Is we're using a continuous number line here that has decimals and fractions. And has all these numbers on it. But we're talking about a discrete variable, people. People is a discrete variable because you have to have 10 or 11 or 12. So because of that, we have to make a little bit of a correction that you're going to see here in a minute. You also need to calculate the standard deviation. Standard deviation of a binomial distribution is the square root of n times p times q. So you're going to type in the square root of 180 times 0.06 times 0.94. That comes up to 3.186. All right, the first question. What's the probability that exactly 4 read the newspaper? So 4 is going to be less than 10.8, so you go down here to the left somewhere. There's 4. Now, this is where the correction comes into play. You can't find the area between 4 and 4 because there wouldn't be any area. You have to find the area between 3.5 drivers and 4.5 drivers. That area represents 4 drivers. I'm going to find this area right here. That area will give me the probability that exactly 4 people read the newspaper while driving. So what I need to do is I need to convert both of these x values, these are both values of x, into z-scores. So to get my first z-score, I would take 3.5 minus 10.8 divided by my standard deviation of 3.186. That will give me a z-score of, I think I have it on my notes here somewhere, negative 2.29. That tells me 3.5 is 2.29 standard deviations below the mean. Next, I go to my z-chart. I look up 2.29, so I look up 2.2 on the left, 0.09 at the top. I come over, I come down, and that answer will give me the area between 3.5 and 10.8. Give me that area right there. So we're going to need to get out a z-chart for that. So you look on your z-chart. Whoops, that doesn't have a z-chart on that. Let's try that again. Here we go. Look at your z-chart and go to 2.2 on the left side. Go to 0.09 down the right side. And I'm seeing 0.4890. That look right? Anyone else see that? 0.4890. So that is the area between a z-score, or that's the area between 3.5 and 10.8. This area is 0.4890. Any questions about that? All right, next, let's find the z-score for 4.5. It's a different color here. This z-score, we're going to do 4.5 minus the mean of 10.8 divided by the standard deviation of 3.186. And I'm going to put that in black to make sure the camera can pick that up. So go ahead and you calculate that using your calculator. Once you find that z-score, you'll look up your area, your corresponding area on your z-chart. That z-score is, now notice 4.5 is closer to the mean, so I should get a z-score that's closer to 0 this time. And your z-scores you're going to round to 2 decimal places. So on this one I'm seeing a z-score of negative 1.98, meaning that 4.5 is 1.98 standard deviations below the mean. So I go to 1.9, I go to 0.08, I come over, I come down. Anyone know what that area is? No, we'll look it up.
Like 4761.
0.4761, is that what you said? Okay. 0.4761. That area would be right here. 0.4761 is this area. So I know this total area from 3.5 to 10.8. I know the area from 4.5 to 10.8. So how would I find this, just this black striped strip right here?
Subtract.
No, subtract it. Yep. If you know this total and you know this area, you can find this strip and subtract it. Take your bigger area minus your smaller area, and you're going to get this area right here. So to get this first answer, what's the probability exactly 4 read the newspaper? You're going to take 0.4890 minus 0.4761. That's going to give you an answer of 0.0029. Does that look right? So, in other words, there's only a 29 out of 10,000 chance that if you went out and surveyed 180 drivers, that exactly 4 of them would say, yes, I drive the newspaper. So not very likely, 29 out of 10,000. But look at B. What's the probability that more than 4 read the newspaper? Well, more than 4 would be from which number to the right? I go 3.5, 4.5, or 4 to the right.
Four and a half.
Yeah, 4.5, because you have to understand that anything between 3.5 and 4.5 is considered 4, would round to 4. So when they say more than 4, we don't want to include the strip. We want to include this area plus this area, which would be 0.5. So to get the probability that more than 4 read the newspaper, I would take 0.4761 plus 0.5. So that would be 0.9761. In other words, there's about a 97.6% chance that if I surveyed 180 drivers, that more than 4 of them would say they read the newspaper already. Any questions about that answer? All right, last thing. What's the probability that at least 4 read the newspaper? At least 4 meaning 4 or more. So 4 or more would mean I want to include this strip that includes 4 plus everything to the right. So which two numbers would I want to add together this time?
0.4890 plus 0.5.
Right, to get this total area, 0.4890 plus 0.50 or 0.5 would give me 0.9890. So I'd add this number and this number. And again, the reason that we use the decimals here is called a correction for continuity, where it's because we're using a continuous graph to represent a discrete variable, so we have to make that adjustment.